Dear students, a very good evening. Today is the third day of the certificate course in Life on the Space and Exogeology. Today we are going to talking about the very special topic with the very dedicated scientist. Let me give some few times to introduce our guest speaker on today. She's the Director Academic of Eco Astronomy INC Network. Through the Eco Astronomy online certificate program, she has been hosted more than 150 scientific podcast events since 2018. Our dedicated speaker is an active member of IUCN three commissions of the education and communication, commissions of the ecosystem management, and the commissions of the climate crisis. She is well known for hosting international scientific events and debates, as well as she is delivering many international national lectures for many students groups of age universities and some institutions from the Morocco, China, Sri Lanka, Turkey, Pakistan, East Asia, Europe, and the Canada. By the 2021, she has been successfully compiled her international second master degree, as well as currently she is doing her second Ph.D. in Beijing Forestry University. She's thoroughly focusing on marine science and the technology. She has been appointed as an international student advisor and the ambassador at the Beijing Forestry University International College in Beijing, China. During this period, she has been performed plenty of valuable international work related to scientific research and the social as well as a communications development. She have more than 11 years skills, a research experience, and also like a podcast experience. She's the best scientist ever we had in Eco Astronomy Sri Lanka, a platform. And also like her leadership, her soft skills are thoroughly helping up to develop many of our motivated students. Up to now, she has been published more than 10 international research papers, including 4 books, and she won 7 awards. So like she's the one of our best dedicated scientists ever we had. It's because of the path that we have been created for our young aspiring scientists. She is the mother, and she has been done a tremendous work for developing such a academic platforms in Sri Lanka, India, Morocco, China, and the Singapore. With that being said, I would like to invite one of a talented speaker, Director Academic of Ecoastronomy, INC International Network, Dr. Engineer Majda Aouititen, to talking about how to study the Earth ecosystem from the space. The engineer Majda Aouititen, this is your time. You can get started. Thank you very much.
Thank you so much for this beautiful and kind introduction. Actually, it is always very amazing to hear such a good introduction. Thank you so much, Dr. Arvinda, for your beautiful words and for your introduction. Today, as we have mentioned, we are going to talk about how to study Earth ecosystems from space. Are you ready? So let's get started, shall we? First thing first, I want to give you a brief guide through today's outlines. So in the first place, I'm going to give you an introduction about how to study Earth ecosystem from space, or what is it actually all about. And then we are going to talk about a remote sensing technology that will allow us to conduct these Earth ecosystem studies from space. And also afterwards, I'm going to share with you the key ecosystems observed from space. And after that, we are going to head and explain deeply what is the application in ecology and conservation that we can use this space technology to help us understand these ecosystems and conduct these surveys. And also, I'm going to share with you case studies of Earth's ecosystems observation from space that personally I use to conduct my research as engineer in ecology and biodiversity management, and also for my 2 PhD degrees. Now also, after sharing with you and discover the case studies, we are going to talk about the funniest activities where we can use the satellite images interpretation. Actually, here we are going to have fun. I'm gonna share with you some pictures, and you guys gonna tell me what these images, the satellite images, reflect. Do not worry, I'm gonna explain everything, and when we're gonna have this fun activity, you're going to have like strong background to answer these questions. And then we are going to talk about the future of remote sensing in ecology. As you know, you guys, right now we are talking about a huge shift in technology when we are talking about ChatGPT, AI. So we are going to see how these technology gonna help us to improve or to see the upcoming future of remote sensing in ecology. Now you guys have a brief understanding of what we are going to talk about today. Shall we dive into today's lecture? So let's get started. It's not moving. Oh goodness. Let me just use mechanism type of techniques. So the first thing that we are going to discover today is an introduction about these Earth ecosystems study from space. You guys, I have a question for you. Do you think that we can use space technology to study Earth ecosystems? Please answer by yes or no in the comment box or by raising your hands. I need to hear your voices. Do you think that we can use space science to study our Earth ecosystems? What do you think? Anyone? It's a yes or no question. Yeah, go ahead. Indusara, go ahead.
Yes, ma'am. I think we can study Earth's ecosystems from space.
Very good. As Indusara have confirmed, yes, indeed, we can use space technology that we have to study Earth ecosystems. Now I have another questions for you, and I want other students to answer, not Indusara, another one. You guys, did you think that can we use NASA's space technology to study Earth ecosystems? Yeah, go ahead, Neil.
Yeah, for sure. I think it will be possible.
Very good. Now I want you guys, any other ISO Kandika or Shandika, can you tell me if there is another example of like space agency who can help us study Earth ecosystems? You have any idea?
Yeah, I think maybe because when we compare about Earth and space, maybe there's some kind of relationship, so we can study Earth by using space technology.
Very good. Now I said if there is any other type of organization like NASA or institution who can help us study Earth ecosystems from space. I have mentioned NASA. Yeah, go ahead, Ovinda.
There is ESA and ISRO.
Super good. Did you have any other idea about any type of institution's name who can help us, who give us data about our Earth by using space satellites? Other institutions. Okay, let me see. I still see Anthony. Go ahead.
Europe Space Agency can help us.
Yeah, have been mentioned already. Do you have any other type of institution or organization?
And ISRO.
Huh?
ISRO.
Can you give me the whole name?
Indian Space Rocket Organization.
Rocket. I have no idea about what institutions or what data can they offer to the public. They did offer like public data, or because when we are talking about NASA, they are offering data for public, for scientists like me, like you in the future. You can go, you can see the data in their website. I have no idea about India if they did put the data accessible for public. Now also, Anushi, go ahead.
JAXA.
Huh?
JAXA.
Can you guys give me the whole name?
Japan Space Agency.
Why you're talking so like Can you
Japan
now
Space Agency.
Japan, you said?
Yes. JAXA.
Can you speak louder, my dear? Speak louder so we're not gonna lose our time, okay?
JAXA. Japan Space Agency.
Okay, they did share the data in public platform?
I think.
You think? Okay, we're going to, like, you and also Peter, you guys, you have to check for me if you can find website where these two agencies that you have mentioned, one in Japan and one in India, if they share the data, their data for public. Indusara, go ahead, dear.
NOAA, National
Noah, good one, good one. Can you tell the whole name for the people who didn't know?
National Oceanic and Atmospheric Administration.
Excellent, excellent. Very good. Tirandi, go ahead. Or Tehrandi, go ahead.
SpaceX and China National Space Administration.
Okay, are you sure they are going to share their data for public accesses?
Little bit.
Little bit? Okay, so you're the third student in the list that you guys, I want you to search and to confirm if those agencies or institutions, they did offer an access to their data, okay? This is very good. So now you guys have a better understanding of what's the meaning of studying Earth ecosystems from space. Now let's dive into it, shall we? Actually, I want you to understand that studying Earth ecosystem from space involves using satellite to monitor the change that will happen or that we can observe. This is actually an amazing step forward that helps scientists to understand the changes that happening in our planet Earth. Yes, NASA making a lot of missions for other planets, but actually NASA have been created first. All the potential that NASA have used first, it was like observing our planet Earth. And what NASA is doing right now is studying other planets, right? So it's not something weird that NASA or the European Space Agency are conducting research about our planet. But the beautiful of this potential is that we as a scientist, you as a future scientist, can have access to this amazing and powerful knowledge to make your research without going every single day to the ocean to collect data about the sea surface temperature, sea salinity, for example, to see if there is any type of like plankton, new plankton happening. You can have all this data based on the satellite type of data that these beautiful like institutions, they share for the benefits of all the public. Now also, these satellites help us not only to monitor, but also to understand various ecological processing and change that happening around. For example, I'm here in China. How I would know that there is, for example, a high level of temperature happening in the Mediterranean Sea? I am not there, but believe me, right now I can enter through the NASA website or other website that I'm gonna share with you through the lecture today. I can enter, I can see, I can check the date, I can check the the time, I can check also the measurements. They will give me exact, precise type of data to make me understand what is happening right now in the Mediterranean Sea. This is, for me as a scientist, is huge, because you guys, I have started my research in the scientific world in 2011. So in 2011, what I was as a scientist doing, I was going to the sea, because my research was focusing on studying the sea ecosystem of our gorgeous planet Earth, in the Mediterranean Sea specifically. So I used to go every single day to take the measurement of the sea surface temperature, of the sea surface salinity. But I am a human as well. I couldn't stay there forever. I need to go to eat. I need to go to like have other type of activities. I have a family. So life was super much harder. But when NASA and other agencies and the other space like organizations have allowed this data catched from satellite to be shared with public, it have changed greatly the scientist type of like perspective. It have changed our ability to also give solid data, to analyze solid data, because you have a very huge bunch of data that you can analyze, and also you can have a very good conclusion based on that huge number of data. Now we have understand what is actually the Earth ecosystems study that happened or happening from space. Now let's move on to the second aspect of our lecture today. Now you guys gonna ask me, right, what is the importance actually of all of these? We can do the same thing. We can still go to our marine ecosystems or our forest ecosystem or whatever Earth ecosystem, and we can do it. It doesn't bother us. What is the importance of these satellites to help us? Well, as I mentioned first, you can do it from your home. I can do it from China here, while the data I want is in the Mediterranean, in the Mediterranean Sea. So can you imagine how much time I gain, how much money I gain, how much effort I gain? It's super amazing. And also it will provide you a comprehensive view of the ecosystem change actually. If a human collect the data, indeed, it will allow you to have an understanding, a comprehensive view of what is happening in our beautiful Earth ecosystems. But it's not gonna be quickly. It's gonna take a long time to collect all this data, to have that comprehensive type of, oh, now I know this change is happening. But if we are using satellites or using space science or space technology to help us understand what is actually happening in our Earth ecosystems, that's gonna be super quick. For example, I'm gonna give you a very simple example. I believe in Sri Lanka we have a lot of, sometimes we have hurricanes, right? And other places in our beautiful planet, like for example in Florida, we have hurricanes. How they did notice in these hurricanes? By satellites. They monitor these hurricanes by satellites. Also in China, same thing. We have the information that a hurricane is coming before the hurricane surprises us, so we can have time to protect ourselves. These are the change monitoring type of study. Now, if we are going to take the scientific visualization studio, NASA actually have give us a very deep understanding of the importance of this Earth system observation. They have managed 1, 2, 3, 4, 5. They have managed the explanation in 5 aspects. The CCP, which is they are monitoring the clouds convection and precipitation. You know, this is in every single day. You can watch your news and you know if it's gonna rain, if not gonna rain, how much it's gonna rain. this is in the prehistoric era or this in the 17th, nobody will be able to predict or to assume. This is science. We are not predicting. We are making an analysis based on the data we have, and we're giving the information. You guys, you are going to have this amount of rain. So prepare yourself. If it is dangerous, there is a hurricane coming. Prepare yourself. Move yourself from this area. This is amazing. And we have the aerosols also. They are using, NASA, they are using this type of technology to collect and monitor the aerosols and specifically the particles in the atmosphere. This is super complex to be understood. However, I want you just to take a fundamental understanding of it. Now, also they are monitoring the mass change on the Earth, and also they are monitoring the CBG, which is actually the surface biology and geology, and they are as well monitoring the surface deformation and change. Can you imagine? They are going so deep in this study. They are not just making studying what I study, just the change of the relevant sea parameters. No, they are actually studying how this beautiful planet is actually behaving when it comes to air, when it comes to the surface, when it comes to the core of our Earth. This is a system. They are actually using this space science and this monitoring type of study to have a better understanding of what is this beautiful planet Earth all about. Because you guys, you have to remember, our planet Earth is the only planet in our solar system till now that have a strong, very complex life system that have been not found in any other place. So for those great organization and institution like NASA and the European Space Science and the other agencies from all around the globe, studying Earth gonna help them have a better understanding of what is happening in another planet. And maybe studying Earth will give them the key component to help developing life in other planets. So it's better to start understanding what is happening here and now in this gorgeous planet if you want to know what is happened or what is gonna happen in Mars. Now, this have been said, let's now talk about how we do this study. I have explained that indeed this study is very important, and you guys have explained that absolutely we use space science to understand the ecosystems of our beautiful planet. We have talked about the importance of this study, why it is important. We have dived deep that indeed for a better understanding of other planets, it's better to start understanding what we have right here, right now, which is our planet, our beautiful planet, and our complex life system that have been developed in this beautiful planet. Now, the next question, the next normal question is, but wait, how they do that? A satellite, yes, but how it's functioning? Actually, how this is functioning? Let me explain for you how this is actually functioning up there. So it's all, we can make a conclusion of the system that have helped us catch this information about our beautiful planet Earth ecosystem. We can mention the remote sensing technology. When scientists, they have had that discovery of remote sensing, that day they have won the jackpot, because they will be having a very huge amount of data that will help them develop a lot of better understanding. What is a remote sensing? This is the right question to ask. Well, remote sensing actually involves collecting data about the Earth's surface. As you can see here, we have here like here we have a satellite, and the satellite will receive a reflection through some type of energy. This is one type. We're going to talk about it. So this remote sensing, which involves the collection of the data that will be reflected like from the Earth's surface and received through the satellite, or gonna be also received through an aerial sensor technology, like for example here, this what we call the remote sensing. Let me dive deep. What is a remote sensing? Actually, we know right now that we have two types of remote sensing. I want you to take I want you to be very careful here and to focus. So the two types of remote sensing that we have the active sensors and we have the passive sensors, okay? And we have here a graph that I'm gonna explain to you. So the active sensors, what is it? The active sensors is when, like, the active sensor gonna send the signal, as you can see here, sending a signal, and the reflection that will return gonna be measured. This is what we call the active sensor, and that measurement that we are going to receive is gonna be actually, we gonna produce our data based on that measurement. So remember, active sensors is like we gonna receive a signal, we gonna send a signal, and then the reflection that we are going to receive, we gonna measure it. So this is why we said active. Now, the passive sensor. Why we said passive sensor? Actually, we are not gonna send a signal at all. This is what we said passive. What we are going to do, we are going to enter directly in the measurement. Measurements of what? We are going to measure the radiation that the light will create. And also, we are going to measure sometimes the heat. Sometimes, like for example, I am sitting under the sun and my body is gonna be super warm. Like for example, imagine me walking into the desert, okay? So the satellite gonna receive a reflection of heat. I'm gonna look red. I'm not gonna, like my hair not gonna appear at all. So that will be, the satellite gonna receive a thermal type of like reflection. This is why we said passive sensors. I hope that you get it. So the passive sensors have two type of aspect to it. We have the optical. The optical is the reflection. The satellite gonna receive the measurement of reflection, of reflecting the light from something, the sun's light. And the thermal here, the thermal is the heat. When I am very, very, very warm, or when I am dead cold, I'm gonna look blue. If I look blue, so my satellite gonna say this thing is dead. Have no like significant thermal activities. Now, the active sensors, we use lidar and radar. We're gonna dive deep in what is the lidar and radar, okay? Because this is very important. I just like want you to have a very better understanding. So how the radars work? Here, a very good explanation. Focus with me and take your time to understand. So the radar, here, picture one, the radar sends out electromagnetic waves, okay? So the radar work with sending wave, like electromagnetic waves. And the second step gonna be, the waves are sent back to the radar. And the change between the sent electromagnetic wave and the return electromagnetic wave is the measurements that we are going to consider. That's our data, okay? Now, how does lidar work? I know, you guys, I didn't want you to get confused between radar and lidar. So here, how the lidar works. Actually, LiDAR sensor sends light pulses. It's like a laser, okay? Imagine just laser. LiDAR use laser. So our drone here send a laser to a ground, okay? And the pulse returning from the sensor, it will return to the sensor. When the pulses return, so the time gap between when we have sent the laser and when we have catch it up, return it back, the time differences, that will be our measurements. That will be our data, okay? So the first one, the radar, is using electromagnetic, and the data actually is calculated by the change of the first wave, electronic wave, and the last one. What have happened? The change that have happened is our data. Now the LiDAR we use to send laser, lights, pulses, and when we will receive it again as a reflection, then the time gap that we did have sending and waiting to return, that will be our measurement, our data. Now I'm gonna ask you, radar, LiDAR, what about sonar? Sonar, you guys, is much more amazing because this is my area of research. Sonar actually is the measurement of sound waves, and we use it to study the marine ecosystem and the marine like areas covered by water, because you guys, till now, satellites can see everywhere. However, they didn't enter through deep into the ocean or into the sea. So for us as scientists, what we should do to study very deep type of ecosystems, we use the sonar. The sonar is the better technology to use to study deep marine ecosystems. Now let's have some fun. This is the first question that I want you to answer and see if you guys did get some understanding of what we have talked about. Now, my question is radar good for underwater studies? You can raise your hand so I can see, and then you can answer your question once I call your name. Yeah, I see whom? Indusara, go ahead, dear.
Yes, ma'am. I think radar is the best way to study marine life because light is not very good at traveling underwater. Also, radar signals are not that good. No, radar signals are not that good, but sound waves can travel through water more quickly.
Listen what you are saying. You are saying a lot of things that have no connection with each other. You are saying correct things, but in the same time you are saying wrong things. My question is, read here, is radar good for underwater studies?
Yes, ma'am.
You said yes.
Yes.
Okay. I'm gonna go to another student and we are going then to return to you, Indusara. The second student, let me see. Second student gonna be Yuvin. Go ahead.
Teacher, I also think the radar is good for underwater studies because normally if you put a light wave instead of a sound wave, it's not going to travel through water that properly. And
you
so
guys, be careful of what you are saying. You are saying correct things, but you are making wrong conclusions. I'm gonna return to you, Yuvin and Indusara. Let me see the third student, Tanitma. Go ahead, dear.
Yes, madam. I also think radar is good. First, it's sonar. Sonar is the best, and then it's radar because
My
electromagnetic
question
wave.
is very clear. You guys are not taking attention of what my question is. You guys, three of you make the same mistakes. Is radar good for underwater studies? Be
Yes, madam.
careful. Yes, you said yes. Right? What did you said?
Madam, I guess because electromagnetic waves can pass through water so fast. So I guess it is also a good method to study underwater using radar.
Okay. Shanitma, I'm gonna return to you with Yuvin and Indusara. Ovinda, go ahead, dear.
I think it's no, because the waves are going to reflect at the surface of the water. So it might not go underwater.
Very good, Ovinda. Super good. Can you explain it one more time to your friends?
So the waves are going to reflect at the surface of the water and not go through the water. So we will get a wrong measurement.
Absolutely. Ovinda, can you help me? Radar is what actually? What we have said. The radar we use what? Electromagnetic wave, right?
Yes, radio waves, yeah, electromagnetic waves.
Yeah, these electromagnetic waves can be actually very cannot go through very deep sea water. It can reach just few feet of water and then reject it. So the radar electromagnetic waves are not strong to help us study underwater. I hope Indusara, Yuvin, Shanitma get the idea. Because you guys, three of you, you have mentioned sonar during your explanation. And you make the same mistake. You mistaken radar with sonar. It's not the same. The radar, we use electromagnetic wave. The sonar, we use sound wave. Let me see. Indusara, what do you think right now?
Yes, ma'am. I think radar is not good at underwater studies. I understand my mistake.
Did you understand it right? Because you was the first one to said, and because the sonar, and I was like, oh goodness, you actually have a good understanding of radar, but you misunderstand what is radar and sonar together.
Yes, ma'am. I think I have misunderstood them.
Well, I hope right now is clear. Let me now ask Yuvin. Yuvin, dear, what do you think right now?
Yes, I also think radar is good. The thing is, I actually mixed up radar and sonar.
Well, right now, is radar good for underwater studies? What do you think?
No, because the waves will reflect the electromagnetic signals.
Well, because the radar using electromagnetic waves. This is why it's not gonna be like dive deep into the water. It's gonna be rejected at some feet.
Okay.
Okay. Good. Shanitma, dear, what do you think right now?
Madam, can I ask a small question?
Of course, go ahead.
Madam, there are different types of electromagnetic waves, no? So none of them can pass through underwater? Or...
Radar, it can reach some feet. They gonna not be able to reach deep, like type of deepness into the sea because of the water component itself. To study the water, like to study an ecosystem under the water, it needs specific type of waves. The best one we had till now that I know is the sound wave, which we call it like sonar.
Okay, madam, thank you. I understood it.
You're very welcome. Now my question is Is radar good for underwater studies based on what I have explained till now? Janitma, my question to you. I'm still waiting for your answer.
Now I can understand, madam, that radar is not the best and it is really not good to study about underwater because we can't dive into the deep underwater studies. We can just study from about the surface from these radars.
Yeah, we can reach some few feet, maybe 30 feet of like the water underwater, but not that much deep. Well, I have another questions for you guys. The 4 students who have already answered the first question not gonna participate in the other questions. You guys, you can just put your hand down so other students can raise their hands so I can see them. Okay, thank you. Now, is radar recommended for underwater studies? What do you think? Yuvin, you have already answered the question. I need other students. Thank you, dear. I need other students to answer this question. Is radar recommended for underwater studies? You can raise your hand. I need to see all your hands up. Dr. Arvinda, you can help me if you see any students' hands up because I can see none. Otherwise, I'm gonna call your names one by one.
Yeah, still I can't see none of hands.
You can select one for me, Dr. Arvinda. Go ahead. The floor is yours right now.
Okay, dear. Okay, 10 o'clock. Go ahead.
Yeah, go ahead, dear. Go ahead.
Yes, radar can.
Good. You said radar can. Can you tell me based on what radar can be recommended to study the underwater? What radar used to study the underwater? There is a need of a key component. Actually, I need to tell you that radar is the light detection and ranging. Radar, listen carefully. Radar is the light detection and ranging. Okay, so what radar use to reflect and collect the data? I see whom? Anthony, go ahead, Anthony.
Yeah.
Ma'am, you mean what radar uses? It uses light to find the distance.
You said light, right?
Yeah, ma'am.
Very good. You guys, you have had a very good understanding. Indeed, radar use light to study or to make to collect data of the reflection that's the system will receive to collect the data. Now my question is, if the machine have no light, are we gonna be able to measure the ecosystem that we are, the underwater ecosystem, if we are going so deep? You know, in deep side of the ocean there is no light, you know that. What about that side? Is the radar gonna be recommended for this underwater studies?
I think no, ma'am.
Not you, not you. You have already answered. I need other students. Chandika, yeah, Chandika, go ahead.
Yes, Chandika.
I think it's not really a good recommendation because radar uses light, so I guess it's not a good option. It might be good for.
Is it? Do you mean is not recommended for all the underwater marine ecosystem, or for just some type of like deep ecosystems? in the marine ecosystems and environment? What do you mean?
I think that it might be good for the higher sea levels, but I don't think it will be good for when you go deeper into the ocean.
Well, actually, if we send our machine here with the light, as you can see here, it will be able to detect and to collect the data. However, if something happened and that light have disappeared and there is no light at all in this deep side of the marine ecosystem that we are sending our machine to collect the data from, we're not going to be able to collect that data. Now, if we compare the LiDAR with the radar, the LiDAR is much more recommended for marine studies, and there is a maximum feet of studies that we can use this LiDAR to. Some scientists, they said 13 meters, some others, they said more. It will depend on the lights and only on the lights of that ecosystem. Now, I'm very proud of all of you guys. Now you did have a better understanding. You guys, if you have answered, put your hand down and let other students who didn't interact have their chance to interact. The third question, this is gonna be easy. Is a sonar the best for underwater studies? Yes, go ahead, Niruj.
According to me, sonar is the best way to study in underwater because sonar, the sound waves can travel in water so fast, so it can give a very efficient data.
Very good. You guys, now you did have a better understanding of what is the differences between this radar, this sonar, and this LiDAR. So now you know. Now, if any scientist or if you have attended any type of conferences or your professor is explaining to you these type of concepts, now you have an understanding. And now you will know why in the water we use sonar, but we didn't use other type of machinery or technology. Because when you use the best technology, you are not going to lose a lot of money. We can use LiDAR for water studies, but we are going to lose a lot of money. We didn't want to lose a lot of money. Always, when you think in science, always search for the best way and the cheapest way. Best way means the accurate one and the cheapest one. Okay? So let's continue our work. Now, these instruments that we have from space, the satellites we have, for example, we have these beautiful satellites that is rotating right now. Its name is it's moderate resolution imaging spectroradiometry. It will help us catch a lot of very valuable data based on the satellite based sensoring measurement that they will catch from Earth. Based on, they will give us understanding of the climate that we are having in our beautiful planet Earth, and that will help us also studying the changes of this climate in our Earth. Now, also, when we talk about the satellites that have allowed us to collect all of this data about our marine ecosystems, our forest ecosystems, the change that is happening. You guys, I think we should know their names, because those machinery, those type of satellites, they are helping us monitoring our planet Earth. They are giving us very valuable data to help us make strong decisions when it comes to marine protection, conservation, forest deforestation, conservation. When it comes to our planet, decision making to protect our human life in the first place, we consider these data. Actually, it's not just a satellite rotating around our planet. No, it's a huge, important technology that it's allowing us to take very valuable information about what is happening in our planet right now in every single point of it. And based on this data, we are going in a right direction to predict some very dangerous type of changes that is happening right now in our planet. And based on that knowledge, we are trying to develop very good conservation, to come up with very strong type of legislations to help protect our beautiful planet. So one of the satellites that they are giving us this data is actually this one. It's Landsat Satellite 7. Actually, they have launched 9 satellites, 9 Landsat satellites, and this is number 7 here. Actually, why I choose number 7? Because I love number 7. It's a very strong number, but because it is huge, if you can see. Now, the other satellite that they have launched after number 7, it's number number 7, 8, and 9, 2 others, and they are not that much bigger than satellite number 7. I do not know why. Maybe because the technology have changed and have developed. But like also every single Landsat satellite have its own mission and have its own type of measurement that this satellite is recommended to do. Each satellite, those 9 satellites, some of them, they complete each other's data monitoring, and also some of them, they do other collection of data. So till now, those are 9 satellites from this joint program between these 2 amazing agencies and institutions. We have also another project. We have 2 remote sensing types, an active remote sensing and a passive remote sensing. Which one is active and which one is passive? Go ahead. Who is gonna be first? You, Vindy, go ahead.
Teacher, I think the passive one is 1 and the active one is 2.
Okay, thank you. Next one.
Anushi, go ahead.
Just let me tell you something. Those who have answered, please put your hand down so others can go up so we can see them. Okay.
The first one is passive and the second one is active.
Who is speaking?
Anushi.
Anushi said the passive one is 1, right?
Yes.
Thank you. Who is gonna be next?
Then Indusara, go ahead.
Madam, I think the number 1 satellite uses passive sensing technology and number 2 satellite uses active sensing technology.
So you said the first one is passive and the second one is active, right?
Yes, ma'am. First one is passive and the second one is active.
Thank you so much. The second one, the next one. And there is a problem. I hear somebody is like humming in the background. Can you close your microphone, please, so we can hear ourselves clearly? Thank you. Who is the next?
Daksha, go ahead.
Ma'am, I think the first one is passive sensors and the second one is active sensors.
Thank you, dear. Daksha, thank you. Who is next?
Then Vihanga, go ahead.
I think the first one is passive sensing and the second one is active sensing.
Thank you, dear. Next one.
Then Chanitma, go ahead.
Madam, first one is an example for passive sensor and the second one for example for active sensor.
Thank you, dear. Next one.
Pasidu?
Madam, I think first one is passive sensor and second one is active sensor.
Thank you, dear. Next one.
Okay, Niruj?
Madam, according to me, first one is the passive sensor and second one is the active sensor.
Thank you, dear. Next one.
Avinda?
First one is passive, second one is active.
Thank you, dear. Next one.
Okay, Chamira? Chamisha?
And Chamisha the
I didn't hear you. Can you repeat?
the first one.
The first one is
Passive.
and the second one is
Active.
Thank you, Shamisa. Next one.
Then Tenacon.
Madam, I think the first one is passive sensor and the second one is active sensor.
Thank you, dear. Next one.
Ishan?
First one is passive and second one is active.
Thank you, dear. Next one.
Supeshala?
Madam, the first one is passive sensing and the second one is active sensing.
Thank you, dear. Next one.
Anthony?
Ma'am, I think the first one is the active one and the second one is passive sensor.
You said the first one. This one picture is active.
Yeah, the first satellite is the second one is passive.
No, dear, focus with me. First picture you said is active, right?
Yeah, ma'am.
And the second one is passive, you said.
Yeah, ma'am.
Your name is Anthony, right?
Ma'am, I couldn't see the picture properly, ma'am. Can you hear me?
I can hear you. You can see the, can I describe for you the first picture and the second picture and you told me?
Yeah, ma'am. Can you, shall I couldn't see the picture properly. Can
I
you
will
describe
it for you. I will describe it for you. So the first picture, we have a satellite and we have the sun, and the sun is sending its radiation through the earth, and its radiation returning to the satellite. So is this an active remote sensing or passive one?
The first one is a passive one.
You see, right now you do good things. Yeah, first one is passive one. And what is an active remote sensing?
It doesn't send a signal. It only receives one.
Very good. Thank you, dear. Who is next?
Then Pawan?
Ma'am, I think the first one is passive sensing and the second one is active sensing.
Thank you, dear. Go ahead. Next one.
Then
I can't hear.
Tasim Ahmed. You can go ahead.
Ahmed, go ahead.
First one is passive and second one, I think, active.
Okay.
Yeah.
Okay. Next one. Thank you, dear.
Then Umindi.
Thank you, ma'am.
Ma'am, I think the first one is passive and the second one is active.
Thank you, dear. Till next one.
Then Devindi.
Ma'am, I think the first one is passive sensing and the second one is active sensing.
Thank you, dear. Next one.
Then Chandika.
The first one is passive sensing and the second one is active sensing.
Thank you, dear. Next one.
I think all the students have been done.
Okay, Dr. Ravinda, can you do me a favor? Select one student.
Okay, I'm selecting Anthony.
Okay. Anthony, he just did the exercise I want him to do. I want another student. He did get the information. Can you select another one? Not Anthony. Somebody who said the right answer from the beginning till the end, not Anthony.
Ovinder.
Okay. Can you open your microphone, dear?
Hi, yes, I'm here.
Okay. I can't see you. Can you raise your hand so I can see you? Ovinda, right?
Yes, Ovinda.
Okay. So, Ovinda, can you tell me what is the difference between the passive sensoring and the active sensoring?
Okay, so active sensors, we have to send a signal first, some kind of wave, which we are going to detect later. But in passive sensors, we are not sending any kind of waves. We are detecting the waves that are already emitted naturally. Maybe the planet is reflecting something else.
Yeah, our measurement actually is based on the receivements that we are going to receive through what?
Through the sun.
Yes, the sun could be in two forms. Light
and heat.
Light mean reflection, right?
Yes.
Yes. Very good. And very good. You guys, I'm proud of you. Very good. Now let's continue. Now let's continue our journey. So now we are going to talk about the key ecosystems observed from space. Now you guys just relax, okay? Relax. Now we are going to see some very good information for you in the future. If you want to conduct a research, master degree or bachelor degree, I didn't want you to lose a lot of money because we didn't have a lot of money. I want you to be smart, to conduct your research and collect your data, strong data, based on the network. We have network. We can collect all the data we want through this amazing technology that we have in our hands, but a lot of scientists, they didn't know about it. And I want all our students to know about it from now and on. So if you want to do a lecture about something, you're gonna have your data in just like 1 week. You can collect it and analyze it. So let's get started. Here, a very amazing type of key ecosystem from where we use this data for. Actually, for forest, the forest ecosystem. You know, you guys, forests are very important for our daily life. It's not only helping us to manage the oxygen like amount that we have in our atmospheres, but also forests actually provide habitats to many other type of species. And if one species will get extinct, it will have a huge impact. And that impact will not just impact the other species in the chain. No, it will reach us human. This is why right now we are having a lot of allergy. We're having a lot of viruses because we have not that much strong ecosystem to help us destroy some viruses before attending us. We are not strong. We need other species to take care of us. You guys have no idea the importance. For example, look at the bee. You see the bee? You may say, oh, what? Is the bees important in my life? Yes, definitely. The bee is super important in your life, in my life, in our life, in this gorgeous planet Earth. If we will destroy all the bees, who is gonna take care of, like, take the pollen from this tree to another tree? Who gonna make these trees spread all around our planet? If there is no, like, the trees, they will not wake up, oh, today I'm gonna go to Canada to meet my other tree half so I can marry her and have babies. No, it's not gonna happen. Sometimes in the summer there is no wind. You guys in Sri Lanka, maybe you have wind, but if you come to other places, wind is missing. So the tree will not sit, oh my goodness, I will have my seeds, so the wind will come and take my seeds to Canada or to Africa or to South Sri Lanka. No, the bee will take care of that, you see? And other insects will do the same. So we think that, the bees, just they do create milk for us. Not milk, honey for us. That's it. No, you guys. That's what we eat. That's what we consider. And actually, we didn't give them the credit for the honey, the delicious honey, the amazing honey that they give us to heal, not just enjoy, but also to heal our body in the medication type of processing. I'm not gonna go there. It's another topic of discussion. But just like take a second. If there is no insect in this gorgeous planet Earth, there will be huge catastrophe that will happen to the diversity of our forest and plant ecology. You guys have no idea. We are not waiting for an asteroid to come to hit us and to go extinct. We are, as a biologist, we are afraid that we gonna not have that much insects to keep up with the pollution that is happening right now, to keep up the same way in which they keep these ecosystems alive since so long time. So honestly, I'm not scared about an asteroid gonna hit us. I'm much more scared about if any species gonna disappear. What is the consequences? And believe me, right now there is a lot of species, they are disappearing. Now, you may tell me, but what? We are talking about remote sensing. We're talking about space satellite studies. What is this have in connection with what I'm just saying? Well, who is gonna tell me that there is something missing in this forest? We are using satellite database to know if there is a change in the forest topography, to see if there is any forest is disappearing. For example, this type of forest here. We are using space satellites to monitor the deforestation and forest coverage. Actually, you guys, I used this in my second master degree research. I was researching the snub-nosed monkey, seasonal variation and seasonal habitat selection in South China. And I used satellite data to give me an understanding of what is happening actually and why these snub-nosed monkeys are changing their habitat. So you can use this remote sensing technology, this space satellite data to have or to monitor your forest data to see what type, what forest is declining and what forest is increasing and what is happening actually. That based on these type of satellites. Now you're gonna tell me, but teacher, we didn't know what website we can use to have this data. Here is one, free. You guys take a screenshot of this website here, Forest Monitoring Designed for Actions. Okay, take a screenshot. This is a good website that will give you a global forest watch. Either if your country didn't want to, we have satellite up there. We can watch you. This is amazing. So here is the website. If you can see here, I went here to search about forest change. Okay, I clicked on it. And if you can see, Sri Lanka is here. Okay, I am here in Beijing and Sri Lanka in here. Here we can have our, like the indexation. We have the primary forest represented in green. Sri Lanka have a very amazing primary forest, and the pink color is the tree cover loss. This tree cover loss also happening in my home country in Africa due to water, like to precipitation, to climate change, to a lot of things. So as you are in Sri Lanka, I would like you guys to keep protecting your trees, your primary forest, because it have a huge impact on your health, on your also you are not only helping your country, but also you are helping all our planet. You have to take these in consideration. And unfortunately right now, if I will show you the globe scale of the tree coverage loss in all our planet is losing a lot of trees, and that hurt my heart so deeply. So when I see like Sri Lanka, it's still having its primary forest, that makes me super happy, and I want you guys to take great care of your forest. Take this mission deep in your heart, because you are not protecting your country, you are protecting planet Earth, Mother Earth, and that's much more important. I didn't want to cry because I am this is very catching a very citizen ecologist. Now here is the website that I am using. I told you guys it's Copernicus. Here, Copernicus Marine Services. I use this platform. Take this link, take a screenshot. You can tap this and you will have ocean predictions, ocean climate trends. You can have very strong type of analysis that will even predict what is gonna happen in the future. You have oceanscapes reports, you have ocean insights. Also, they are not using only satellites, but also they're using people who gonna observe some change. They collect those data and they put it in this platform. As you can see, I have already my account with them since 2011. As I told you, I used their data often. So this is the most amazing marine product website that will give me this data that I want. And remember what I told you, marine, the Copernicus marine data production, they are using what? They are using the European Space Agency satellites, the SETL that I showed you. Thanks to those satellites swimming right now in around our beautiful Earth, we have this amazing data. Let me show you how it's look. You see, we have global ocean physics analysis. You can see here from January 2019 till October 2024. We have also global ocean biogeochemistry and analysis and forecasts. We have also some some other parameters that will allow you to have a deep understanding. Look at the date. Look at the date. They even give us data from 1993 till today. Can you imagine? This is super good for a scientist who want to really understand what is happening right now for some type of problem that we are studying. For example, I am studying the blooms of jellyfish in the Mediterranean coastline. So for me, the blooms of jellyfish, if I'm gonna take only 5 years or just 11 years, it's not enough to understand why this species is blooming in this season and why not in this season. I need a huge type of data, meaning from 1993 till today, it's gonna be good data for me to make my analysis and to conclude. We're not talking about only one type of data. We're talking about, let me see, we have temperature, sea surface temperature, we have sea surface salinity, we have sea surface height, we have velocity, we have mixed layer thickness, and we have sea ice and others. We have here also carbon. We have plenty of very important sea parameters that as a marine scientist will allow me to make my analysis and to come up with a conclusion why we have this problem right now. Can you imagine if there is no such data, no satellite there giving us this analysis? How as a human I'm gonna be able to conduct my research and to come up with strong analysis? I'm not gonna be able to. Maybe the strongest paper that I will publish is the day after, before I, like the day, one day before I will die. Maybe if I will die in 16 years old, then maybe in 59 years old, I will be able to publish that one paper that I spent all my life going back and forth to collect the data from the ocean to share that paper. But because we have these resources, this plenty of data, now we can publish good papers every single year. That's amazing. This is very huge. So here is how it looks. For example, here we are looking into a heat map and we are seeing the sea surface height above the actually the sea surface height here, and you see our like indexation here, and you just click. For example, I'm studying here, well, this is Morocco, by the way, this is all Morocco, and I am studying my jellyfish in this area. So what I'm doing, I go here, I click on it, I have the location, and you can see here the coordinate of the area, so you're not gonna be lost. You're not gonna select some other place. You have the coordinate, you know exactly where this data is or coming from. Now you can see here this, like the sea surface height is represented by 0.3326 meters. Do you see how exact is this? Even me, if I will do it manually, I'm not gonna come up with such precise type of calculations. I'm gonna do it like 0.3. Why I'm gonna add the other numbers after the 3? You see what I mean? So I recommend these platforms very much for the students who are gonna develop their type of like the research in the future. Now, also we can use the satellite to make an urban like studies or just to see if there is any chance in the urban area. I'm here in China, and for example, I want to see where is the place that Dr. Arvinda mentioned and how it looks like, right? As you can see, here is the name of the street. This is in Colombo, you guys. And I went here through the satellite, Google Maps. Google Maps is for everybody. I think everybody knows how to use Google Maps. I hope so. So you go to Google Map and you just zoom in and use your fundamentals type of understanding, and you zoom till you see, and then you look at this amazing data that actually, for me, it's very valuable, as I know right now how this street how it looks like. Actually, the urban data that we can use through satellite, there is a lot of other platform that they can allow you also to see the change of the habitat, the change of the roads. Also, you can use Google Maps to see if there is change of the roads, or if the roads numbers have grown through time. But Google actually takes so long to give you real-time data. Now, I do not have very deep I didn't use urban analysis satellite methods, but if you guys need it, we can search for you. Now, if you didn't study if you are not doing the assignment for like to see if there is um, more habitat in such an area or such a village, it's okay. You can just like have a better understanding that yes, there is also use for this space science or space technology to monitor what is happening, how many houses have been built this month or this year. So also this is a key component of the space technology. Now we are going to head and discover the applications in ecology and conservation, meaning how, okay, we collect the data. For example, I told you that I collect this data from the website based on the satellite data have been shared for public, and I write my paper, okay? But here we are going to talk about how we can use this data for for ecosystem and conservation. Okay, you will tell me, okay, I have this data, I know this is happening, I know this forest is something is wrong is happening in this forest based on this like data here, but I can't do anything. Well, some people, they start doing things. This is another type of website. Take a picture of it. This website can tell you also the scientific, like they are giving you data about the species that you can find. All right, here you can see this is the jellyfish that I am studying, Pelagia nyctilica. I just go through, I write the name here, and they give me the location of this jellyfish. Actually, this location is based on human observations almost. But now let me show you something. This type of data that we collect, we're gonna use it to understand the climate change monitoring. Me and you, or you in the future, when you are going to become a scientist, do not underestimate the articles that you are going to publish. Do not underestimate the analysis that you are going to publish. By collecting the data, by analyzing it, and by publishing it, you are going to also be an active participant in a better understanding of what is happening in our planet Earth, because not everybody is watching the satellite data that we receive in Copernicus that I showed you, or in NASA website. Those data, they become much more stronger when you as a scientist analyze them and share them and said, hey, people, we have a problem. We have a deforestation here. We have a marine, high sea surface temperature here. What is happening here? So you as a scientist is very needed, your action are very requested. So take this data, analyze it, and publish it. When you publish it, you give it much more strong and powerful energy to be addressed in public. Right now, we all know that there is a climate change happening, but there is no strong actions because people, they are still they are still thinking that, oh, this is normal. This is not normal. Few researchers, they are doing this. They are sharing that there is a change. This has never happened like this. But can you imagine if all the scientists world take this data that we have and analyze it and conclude and make strong conclusion and sharing it, not only in publications, but also we need our scientific community to upgrade. We are in a how we can explain this? We are right now in a very visual type of society. If we can make our research, publish it, and then be invited in for example, in a TV program to talk about your research, and you guys can have that potential to explain what is happening, because a lot of scientists, they couldn't explain to the public what they have concluded, what they have found. We want our scientists here, specifically in Eco Astronomy Sri Lanka, to be able to communicate what they have discovered, because we didn't want your paper or your finding to die in your papers. We want them to be shared in public, and based on your power to share the information that you have discovered through the data that you have collected from this space technology, you're gonna be an active scientist who is doing something good for the planet, who is implementing his knowledge to help conserve our planet. I think our planet right now need a very good communicators from all sides to help protect our planet. Now let's move to the other slide. Now also, as I have mentioned, taking the information from every single ecosystem and analyze it and then start the conservation planning. As a scientist, we always do publish our papers and go to sleep. That's not what these papers should reflect. The papers should be considered as a very important part of the process. We have strong knowledge coming from space technology. We need to use it, we analyze it, we publish it. We need, once that paper have been published, we need to take that information. I'm talking about the people who is taking care of conservation of our planet. They must take that information and start the conservation process, because our planet Earth is in need of conservation right now. We are talking about a very important timing for our planet Earth. I hope you guys gonna lead this change and this development, because till now we are still stuck between publishing and not taking care of what have been published. It's just publishing. It's not. Now we are going to study about some case studies of Earth ecosystems, observation from space that have been already taken in consideration. Here, a very good example. For example, you know the Amazon rainforest, right? It is very important. So, actually, they have developed a satellite type of monitoring for deforestation. What is this actually all about? So, the satellite will monitor the Amazon forest, and every single day we're gonna have pictures, and those pictures will allow us to see if everything is still green or if there is some color appearing on that picture. If there is some color appearing, that means something is happening right there. So what happened? The community, the law enforcement will go there and check, and they will stop what is happening. This is what should happen. Use the information, receiving the information, treating it, analyze it, and then do what you have to do. The law enforcement have act. So receiving the information, analyze, receiving the information, and you as a scientist, receiving the information from the satellite, you as a scientist, you must analyze it and publish it. Then the conservation team or the law enforcement has to take that information that you have published it and analyze it from the satellite and do something and do the action. That's how things must be. And I think based on the technology we have, we're losing a lot of time. And I do not know why we're losing a lot of time to consider this amazing data we have in our hands. Now here, another type of case study. Also, they are using this satellite monitoring to collect information about the corals reef in some oceans. This is actually very important, because you guys, you didn't have to forget that ocean also is a very important source for oxygen in our planet. It's not only because of forests. Oxygen also, the source of oxygen, it's coming from ocean. And for ocean to survive, if you do not have a very healthy coral reef, we are not going to survive. So monitoring our marine ecosystems health and monitoring our forest health is super important for our planet to survive. Now also, they use the satellite information to calculate how many people have been like how many the urbanization, how it's grow through the coast areas. This is also important because I do not recommend people to destroy the coastal areas. The coastal areas must be kept protected for public use because those areas have a very important role in the equilibrium of the marine ecosystem. If you want, we can have another type of discussion about how important is the coastal area for marine ecosystems and for our life and for also stopping the erosion that is happening right now. We can have another discussion, not for today. Now, what we have to talk about, we have some funny activities to do, and you guys, we can have fun. Right now, we are going to discover some satellite images, and you guys have to interpret it. Okay, let's get started. I just want you to tell me what do you understand from this like heat map. What do you understand? Raise your hand and open your microphone once you hear your name and tell me what do you understand this map all about. Very easy. Feel free to describe what you see. Why I'm doing this exercise? Because a scientist need to have imagination and must have a capability of interpretation. Shandika, go ahead, dear. The floor is yours.
I think it's something, a satellite image that is used to represent temperature.
Yes, where?
The Mediterranean Sea.
Yes. SST means the sea surface temperature. So you did have it right. This actually is a heat map from a satellite from Copernicus Marine. As you can see here, the credit goes to Copernicus Marine, the website that I shared with you. And you can see here a representation of the Mediterranean sea surface temperature cumulative trend from 1993 till 2022. And here you have the scale, so you can see which color represent which temperature. Now, you guys, what do you can tell me about this sea surface temperature? What is your conclusion? What do you observe? I need another student. Yuvin, go ahead.
I think, teacher, in this observation, the north side is a bit more hotter than the lower side.
Very good. Oh my goodness, how old are you, Yuvin?
11.
Very good, proud of you. So Yuvin have mentioned that indeed this map showed a very different temperature in the north of the Mediterranean Sea. Going to the east, we can see a very strong sea surface temperature, very high sea surface temperature. When you compare it to the west-south Mediterranean coastline, the sea surface temperature is not that much higher. Let me tell you, Diro, did you know that we can find here a lot of jellyfish in these areas? What conclusion you will make then? Can you make a correlation, a conclusion between high sea surface temperature and the appearance of jellyfish based on this? Anybody? Not you, Vin, somebody else. If you as a scientist, yes, go ahead, Indusara.
Ma'am, I think because of the hot water temperature of the west side of this sea, it attracts more jellyfish?
Absolutely. Good observation, good correlation. Yeah. Because of high sea surface temperature in some areas, for example, Italy here, Italy have much more jellyfish than Spain altogether with Morocco, Algeria, and Tunisia. Can you imagine that? And even in Spain, you can find more jellyfish in here and here in this area. But often the jellyfish actually are very, like they appear every single year, summer season in France and Italy. And if you can see, as you can see here, the heat, like the high temperature is super high if you compare it with other like Mediterranean coastline. Nevertheless, even Morocco have its own jellyfish, but the number of those jellyfish blooms, they are not like compared with the number of the jellyfish that you can find here in Italy. We're talking about like jellyfish, those jellyfish that I'm working about have appeared in Italy since the 17th. And in France, since the 17th, they did record huge number of blooms of jellyfish. However, Morocco, we have registered few blooms of jellyfish starting from 2011. And then they have upgraded. You guys, this map actually, it's not showing every single year temperature. It's a accumulation. So we will need much more other maps to show you the real situation. But I am very happy that you guys have got the the information and the interpretation. Now you can interpret it. Now let's see. If you are working in conservation in Sri Lanka, and part of your job is to conserve your primary forest. Imagine this is your situation, and you have collected these in 2001, this picture, satellite picture. Then 2004, you did collected these. 2007, this one. 10, this one. 2013, this one. 2016, this one. Now, what is your conclusion? And what is these pictures means or represent? Yuvin, go ahead.
Yeah, I think this picture, if we look at this picture, we can understand about the urbanizations, and if I draw a conclusion about this, I see that the amount of urbanization includes very rapidly during the years.
Beautiful, beautiful. So here we have 2001, everything was normal. 2004, something is appearing here. What is this? If you are in conservation of your area, of your forest area, you must go here to check. Is this normal? Who have built this? What is there happening? Then in 2007, it's become much more bigger. Somebody have his own family, and the family have built much more houses. They have built a village here. Is this okay? Maybe it's okay, but maybe this area must be protected. Who knows? Then in 2010, oh goodness, much more deforestation and urbanization. Is it okay? It will depend on the country's legislation. If it is okay, it's okay. But if it is not okay, then this must be stopped. Now we see much more houses, much more urban area, and less trees, less green color. So very good, Yuvin. You have made very good analysis. Now, what we are going to talk about, the future of remote sensing in ecology. Actually, we have already talked about how technology right now have upgraded itself to a very amazing level. Right now, we have ChatGPT. We can discuss with ChatGPT very complex type of knowledge and very type complex topics. And ChatGPT have this quick capability of taking a huge number of references and knowledge and make a conclusion. However, ChatGPT still makes a lot of mistakes, and you as a human, me as a human, we need to always observe what this AI mechanism is giving us as information, and do not rely on it 100%, because those are machines. These machines gonna be gonna make some errors, that for sure. This is why I want to address all the scientist world and communities and tell them to not worry of the competition between human and AI, because AI will never take the human part of the work, because AI will always need a human confirmation, because we use logic, and also we can analyze the results of the AI. And I do have make my own study about ChatGPT type of analysis. I'm talking about ChatGPT, not free version. I'm talking about payable version. And ChatGPT make a lot of error when it comes to analyzing very fundamental type of analysis. And that makes me believe that this AI machinery will always need human monitoring for it. So you guys do not get afraid. Now, what we are going to benefit from it? Well, as a human, I have my concentration capability. My brain will not allow all the data to come up once together. My brain gonna shut down. That for sure. Maybe this is why ChatGPT is making errors randomly. So what is the good that this AI mechanism can offer us? They have the capability of bringing a lot of informations and analyze it and give it to you. What you gonna do? You're gonna just go through the information that this machinery give it to you, go through it, see if it is logical. If it is logical, then consider it. If it is not logical, then redirect your AI to give you much more clear understanding. This is what I do with ChatGPT. I have a very deep conversation with ChatGPT. So we are very glad that we are heading toward a very fantastic type of era, the era of technology, strong technology that will allow us to analyze very complex type of knowledge in very brief time. That will help us make strong decisions, come up with strong planning, not to harm anybody, but to help protect our planet, and also to make strong conclusion. If we want to go in another planet, we can use these machineries to help us make conclusion that we can't see, make potential hypotheses that we can use in other planets to develop life, for example. I believe this new type of technology will help us based on the Earth ecosystem data that we have collected, to have much more hypotheses that we can use to think about and use to work on to develop a better future, not only for Earth, but also for our space journey, to discover other universes, to also understand the very hard physical concepts or metaphysics concepts. So we are heading toward a very good future. Now, also this type of technology and this space science can help us have a global understanding and global collaboration. When we are talking about the European Space Agency that share the Copernicus website with a lot of data, and when we are talking about NASA website also that share a lot of information, NOAA, these are platforms where you can find data that will give you a global knowledge about our planet Earth, and we can collaborate. For me, when I share the data from Copernicus, I mentioned this data coming from Copernicus. This is a collaboration. A global collaboration will help to global decision, because this planet Earth is not only mine or yours, but it's ours. Not for only the good people or the bad people, it's for the good and the bad people. And we need to make decision all together. How are we gonna make a decision all together if we did have a different background, different understanding? Now, based on this technology, we have a global collaboration, we have a global visualization, and we have a global understanding. And we hope in the future, this is gonna help very deeply in the conservation management of our planet Earth. And this is gonna impact also the future of other planets. Now also, it will help education and out research between like all type of scientists, or even if you are not a scientist, just you are a businessman or a businesswoman, or you're a developer, but you like to go through analyzing your ecosystem around you. Your ecosystem, when I'm talking about your ecosystem, I'm talking about your home is your ecosystem. That's one. If you have a garden, it's your ecosystem. If your road, it's your ecosystem. So you guys, the fact that we are going to be able to develop the analysis processing in our thinking, it's not something that we are not used to. No, we are used to it. We are coming from nature, and even if we are living in like villages, or we are living in cities, we have that concept of ecosystem every single day. But the problem is, because we are going toward these technologies, we didn't know that we still like have that concept of ecosystem, and we can manage studying and protecting our ecosystem. Will you allow anybody to come to your home to destroy it? I do not think so. That is you protecting your ecosystem. How you protect your ecosystem? By knowing what is dangerous for your ecosystem and what is good for your ecosystem. How you know? Based on the education you have, based on what you have learned. So education is very important, and these type of technologies will allow us to have a deep understanding. What is this tree all about? What is this flower all about? For example, Dr. Arvinda have a very good type of trees, banana tree that he have in his home like garden, and he told me that that banana used the moonlights, if I'm not mistaken. That was the first time that I'm hearing that information. So that information for me as an ecologist is huge, and for you as a scientist, it will allow you to have much more deeper understanding. Who knows, maybe that banana, we are going to use it for Mars plantation in the future. Who knows? I do not have any idea, but based on the technology and the education and the global education and research we are going to consider, based on the monitoring we're doing and this technology we are having through the satellite, we maybe can have a better like solutions for what plants should we take from here to Mars. Who knows? That's an option. Now for the final part of our class today, I want you to keep in your mind that remote sensing provide a valuable type of insights in the information about our Earth ecosystems. Those satellites swimming all around our planet Earth, they are not only just like materials, but they are actually part of this protected system in this beautiful Earth. So thank you very much to all those organizations and institutes who have developed those type of technology. And also remember that it aid in monitoring change and conservation efforts and understanding biodiversity. Of course, you may say those satellites have another type of missions. I know, but I do not care, because as I mentioned, there is good and there is bad. As much as there is good and there is bad, there is an equilibrium, okay? I care about good. I do not care about bad. That's not my problem. I'm not that side. So and I'm against the one who will tell me, well, if it provides some bad things, so we're not going to use it. This is not how the world have been created. The world have been created with this type of law, good and bad. And if the bad people will reject the technology because there is some bad on it, so those people, they are super inactive, and inactive things always disappear. I do not recommend this type of thinking. Use the good side of everything. Even me, I have a good side and I have a bad side, and I always try to develop my good side to hide my bad side. So you guys remember that this remote sensing provide aid monitoring for change that happening in our planet Earth ecosystems, and will help us to come up with good understanding and good planning for the conservation efforts. Now, remember that empowering the technology actually will develop the ecological research for all researchers. It's not only something that will just like being published in your paper. No, it's something that will have impact in not this generation, but the upcoming generation. They will take this information, as me, I did take a lot of information coming from previous generation, and I make my own conclusion and I publish it. Also, I speak to the public to make awareness, to raise my voice and explain that you guys, this is the time to use this technology to make also our impact in conserving this planet Earth. And also, this conservation may lead directly or indirectly to the development of life in other planets. This is what I believe, and I hope you guys have get my point during this lecture today. So see you soon, dear all and dear talented ones, in other lectures soon. Thank you very much.